Yay! Okay, so today is day 2 of triangles, and we're going to learn about trig ratios. Trig is short for trigonometry. So first, we're going to do a really short homework review, and I think Amy put the link in the chat. There you go. I think you should be able to edit this. Yes. So the first one is, what is the length of x in this 45, 45, 90 triangle? And you guys can put your answer on the Jamboard if you want to. So this one, you just look at the relationship of the sides in a 45, 45, 90 triangle, which is that the legs, if I express them in terms of x, there'd be x, and then the hypotenuse would be x root 2. So this one of the legs is 4, so x must be 4 root 2. 4, 2. There we go.
Okay. For this question, it says to find the value of y, where y is the hypotenuse of this triangle, and the picture shows that this is a 30, 60, 90 triangle. So remember the relationship between the side lengths in a 30, 60, 90 triangle. If we call the side opposite of the 30-degree angle, if we call that x, then the hypotenuse would be twice the length of that. So also the ratio of the length of the longest leg to the length of the short leg is square root of 3. So in other words, if x square root of 3 is 4 square root of 3, then the shorter leg must have a length of 4. And since the length of the hypotenuse is twice the length of the shorter leg, then the hypotenuse has to have a length of 4 times 2, which is 8. So therefore, the value of y is 8.
Okay, last one. What is the length of the short leg of this 30, 60, 90 triangle? So the short leg of this triangle is n. The m1 would be the longer leg. So we just look at the relationship, and we know that the shorter leg is half the length of the hypotenuse. So n would be 3. Any questions about last week's homework? No, then we'll go on to our slides again.
Okay. We're first going to do a quick review of triangle terminology. So in this picture, this is a right triangle, which is indicated by the little square on the corner of the triangle. The side that's opposite the right angle is known as the hypotenuse, and the hypotenuse is the longest side of the right triangle. Now, we also have this angle marked on the right corner of the triangle called the reference angle. That really doesn't mean anything. It just means, well, just think of it as this is the angle we're going to be looking at. That's it. And there's also a little symbol next to that angle. It might be a little hard to see, but this symbol is called theta. It's a Greek letter, and all theta means is that this is an angle. We just use theta to represent the angle measures. You can use anything to represent angle measures, like you can use x, y, z, whatever. It's just in math, they apparently like use theta for angle measures. So looking at the reference angle, the side that is across from the angle on the opposite side of the triangle is called the opposite side because it's it's opposite of the angle. And the side that's next to the reference angle is known as the adjacent side. And the adjacent side can't be the hypotenuse. It's because if you look at the angle, it actually has 2 sides adjacent to it. One of the sides will be the hypotenuse actually, but that's not the adjacent side. The adjacent side is the side that's next to the angle, but not the hypotenuse. And one more thing, generally the reference angle is never the 90-degree angle because then that makes things weird.
This is just like a little slideshow thing.
Oh, yes.
Wait, just like wondering, has anybody done anything with trigonometry here?
Kinda. I mean, in the previous math, I learned a bit about it.
Okay. So I don't think any of you would have learned, well, actually, no. If you're in 8th grade, you probably did learn it in school.
No, this. I think I did that wrong, but like the general base of that. No, wait, sorry, no.
So yeah, I feel like
Yes,
everybody
yeah.
has done a tiny bit, but not too much. And we won't go too much into detail this time. Yes, geometry is learning that. Well, at least you will later in the year. Okay, so we're gonna look at the 3 trigonometric ratios. So these ratios are just like relationships between the side lengths. So not like, yeah, basically. Okay, so the first one is sine, and when we write it as sin, but it's not sin. You keep reading it as sine, not sin. And this one is the ratio between the opposite side and the hypotenuse. So in the triangle to the right, not the left, tell me what the opposite side's length is and the hypotenuse's length is. And the reference angle is the one at the top. That's the reference. Right, so the opposite side length is 3 because that's the side that's opposite of the reference angle. And the hypotenuse is the one opposite of the right angle, so that's 5. And our ratio for sine is opposite over hypotenuse, so it would be opposite 3 over 5. The next one is cosine, and we abbreviate it as COS, but we still read it cosine when we say it, so this would be like cosine of theta. This one we do adjacent over hypotenuse. So the adjacent side length is this one right here because it's the one that's next to our reference angle. Then we just use the hypotenuse again. So it would be 4 over 5. Then the last one we're going to look at is tangent. And tangent we write as TAN. And this one we use the opposite side and the adjacent side. So the opposite is 3, adjacent is 4, so it'd be 3 over 4.
Wait, if the reference angle was a right angle and you had to find the tangent, what would you use as the opposite?
So Amy said like on the last slide, usually like if you put the reference angle as the right angle, you would know what the hypotenuse is, but you wouldn't be able to tell what the opposite side or the adjacent side is because like the 3 and the 4 would also both be adjacent and there'd be no like opposite. So that question is kind of like beyond the scope of this class basically. And all of the problems you'll encounter, at least at this level, won't have the right angle as the reference angle.
Yeah, also as a fun fact, if you try to take the tangent of the 90-degree angle, you get an undefined answer. So
Yeah.
if I can demonstrate with my calculator, tangent 90 degrees, math error, it doesn't like it. So to try not to put the reference angle at 90 degrees because it messes up tangent.
Yes. Okay, so does anybody have any questions about what we're doing right now just on this slide? Okay.
Oh, Aryan, your calculator might have been on radians.
Yeah, probably.
Okay, so the last slide might have had a lot for some people, and that's okay because there's a way to remember what sine, cosine, and tangent stand for. So it's this mnemonic or acronym, I don't even know what it is, called SOHCAHTOA. Basically, the first part, SOH, we say so, and that means sine, so that's the S, equals opposite, which is divided by hypotenuse. So in other words, the side opposite the reference angle divided by the hypotenuse of the triangle. That's what sine is. Then the CAH part, that's cosine. The C equals the adjacent, which is the A, divided by hypotenuse, the H. And so finally, the tangent is just TOA. Tangent is opposite divided by adjacent. So if you have trouble remembering, just remember SOHCAHTOA and try to like sound it out. Then that's how you can remember.
Yep. So now we're gonna do a Desmos activity. So you're gonna go to student.desmos.com and I think, wait, hold on.
Yeah, that's the right code.
I'm gonna like stop sharing my screen now because I don't want to show the teacher dashboard. But basically you're gonna, here, I'll put this in the chat. Z2EW6Y. Okay, now I'll stop sharing my screen. Okay, and so you're gonna go to student.desmos.com and it's gonna prompt you for the code, I think, and you're just gonna put that in. And
should we sign in?
do you have to sign in? If you do, you can just sign in with Google and use your email.
It says you can go on without signing in, but I just wanted to know, should we or should we not?
It doesn't really matter.
It doesn't really matter, but I think it asks you to put in your name anyways, so like you should be fine. And I think everybody should be on the slide 1. So for some reason, some people aren't on slide 1. I don't know how that happened. Wait, is everybody on slide 1?
It's because the restriction thingy, if you move around, everyone shifts.
Yeah, I did move it around, but okay, yeah. So you should be on slide 1 right now. So basically, we're gonna go through the first like 9, I think, slides together. And then after that, we'll give you a tiny bit to do the rest of the slides. So I'm gonna wait like 30 more seconds for more people to join, since there's 18 people right now. Can I put the SOHCAHTOA in the chat? Yeah.
You don't have to sign in with your Google account, do you?
You don't
have to. Just make sure to like put your name. Like I think it should ask you for your name. Let's see how many people are in. Okay, there's 23, so I think we're gonna start. Okay, so yeah, I'll go to the next one. This is just like a little chart of what we just went over, and it shows you the SOHCAHTOA thing again. Okay, so this one is just kind of review from last week, but you can just type your answer in there and press share with class. And the triangle, you just like get to move around for fun. And if you get stuck, you can look at it. So yeah, the angles of a triangle add up to 180 degrees. And you can see that it's always like that, no matter how big or small the triangle is. The next one, wait, just before I go on, is everybody on slide 4 right now, or are some people still on some of the other slides? Okay, so I think everyone's on here now. Okay.
What were slide 1 and 2?
Huh? What was slide 1 and 2? Oh, it wasn't really important. It was just like a welcome message and then some chart that we just went over. Okay, so slide 4.
It was a question because I saw it and I was like,
Oh, that was slide 3.
Wait, you're on slide 3?
Slide 3 was the one with the question about the triangle.
Yeah. It was just like the angles of a triangle add up to 180 degrees. Okay, so I think everybody should be on the 4th slide now. So you can just like put your answer for this using the Pythagorean theorem to find the length of the hypotenuse. And yeah, so you could have just used like some triples if you knew that, but the hypotenuse is 5. So I guess I'll just read this out loud. It is useful to have a way to describe the position of the sides of a triangle. So first you will need a reference angle. It can be one of the other 2 angles other than the right angle. And the reference angle here is like the angle with the red letters, reference angle. And our measures will be in reference to this angle. So the hypotenuse is the longest side of the triangle across from the right angle, and then the opposite side is the one that's across from the reference angle, the side furthest away, and the adjacent side is the one touching the reference angle. So just answer this question, it's pretty simple. If A is a reference angle, which side is the opposite? Yeah, so mostly everybody put BC, which is right. So A, the reference angle is the 50-degree one, and the side opposite of that is BC. Similar question, if C is the reference angle, what is the length of the adjacent side? And we're just practicing this because like you need to be familiar with what the opposite, adjacent, and hypotenuse is in order to do the trig ratios. Yeah, so the adjacent side is 6.72 because there's a lot of good explanations, but one I really like is just that it's next to the reference angle, which is all that really matters for the adjacent side. Okay, we have two more that we're going to go through together. So this one, let angle A represent theta, and drag the labels and place them on the corresponding sides of the right triangle. So I think, let's look at the student view.
We drag them onto the middle of the sides, right? Or do we drag them onto the angle?
So
At the
the
sides.
sides, these would be the sides. You can't have like a opposite angles or hypotenuse angles.
I kind of just put mine in between, in like the middle of the lines, just so like they're confused.
Yeah, that's fine. I can see where you guys put the dots. So as long as it's just in the area of the right line, then you're good. I think everybody like has this down now. So everybody good on figuring out which side is the opposite, which side is the adjacent, and which side is the hypotenuse, right?
Yeah.
Okay, and yeah, sorry if I skipped to the next one too early. You don't really have to explain, I guess. The
Kind of.
last one, how long is the hypotenuse?
Like the overall length, like
So this one, we don't
what?
have a reference angle, right? But no matter what the reference angle is, the hypotenuse is always the same. So tell me the length of the hypotenuse.
Wait, what's the hypotenuse again?
So I guess it
Kinda
kind of gives it
I'm
away,
like-
but I guess I'll tell you. It's the one that's opposite of the right angle, and it's also the longest side of a right triangle.
Oh, okay, I get it.
Yeah, that's good.
I was kind of confused on that.
Yeah, it can be kind of confusing. So yeah, I just explained it, but the right answer would be 8.4. Since that's the longest side and it's also the one that's opposite of the right angle. Okay, so now I'm gonna let you guys pace yourself a little bit on your own from slides 10 through 19.
How do we know which is green? Since there's two blues and one orange.
Wait, which one are you talking about?
Slide 10.
Slide 10. Let's see what you see.
I think there is a green triangle.
I see a green triangle.
Do you see two blue ones?
Well, I guess I'll just tell you the one that's like the top left one is the blue one, and then the biggest one is the green triangle. So it shows up
Can
as
we just write like, can we just write something like 3.4 at 3.74 over 4.9 for the thing, or do we actually have to simplify and solve it?
oh no, you can just like write it.
Oh.
Yeah.
Also, Desmos might actually do it for you. I'm not completely sure, but it might actually do it for you if you type in the numbers.
It did.
It did. Let's see. Yeah, so I believe you can pace yourself until 19. And if you like when you get to 19, just like type in the chat that you're done.
And if you need any help, you can just unmute and ask us and tell us which slide you need help on, or you could put it in the chat.
Yep. So I'm gonna give you about like until until like 3:50ish. Hopefully that's a pretty good time. But
And we might periodically pause in the middle just to, check in and see and like do some of the questions together.
mhm.
So like at the end, we divide the what is it called? The hypotenuse and the opposite.
For which one?
Opposite divided by hypotenuse.
Yes, the last box, yeah.
Oh right, yeah. So like for the first one, would we do 3.74 divided by 4.9?
Yep.
Correct.
Oh, okay.
And just in case somebody gets confused, there's just like some slides that have information on them, but you don't need to like answer anything. So those are just for you to read. I'm confused. Do we just take the opposite and divide by the hypotenuse? For slide 10, yeah, that's all you do basically. So
Can
you
use the
put in,
if we want.
wait, what did you say? I didn't catch that.
Can we use a calculator?
Yeah, of course.
Okay.
You'll probably want to. Some of these numbers are not very friendly.
Actually, the second you like write it as a fraction, it already like it solves it for you.
Oh, really?
Yeah.
You're right. Yeah, so you don't actually have to do anything. If you write it as a fraction and press enter, then Desmos is nice too, and it does it for you.
Wait, what do you mean it does it for you?
So like, here, I'll share my screen for like 1 second. And no, it's not a whole number, it's a decimal. But here. So if I go here, like
Yeah.
for this one, I'm doing the blue triangle, right? So the
Yes.
opposite side is 3.74
And then
and
4
then
point.
4.9. So now I'm gonna press enter just on my keyboard, and it gives me this approximation.
Oh, okay.
Does it work for you too?
I don't think so. I don't know.
Yeah, and if it doesn't, and if it's just in fraction form, that's also fine. I can like tell what you're doing.
It probably works. I'll just use my phone calculator if that's fine.
Yeah, that works too.
Okay. some of the numbers are really long, so can we just like do it within the first few decimals, like 3?
Yeah,
Yeah,
that's fine.
just round wherever you want. Okay, so it's 3:50 and I think most of you guys are done. I see a lot of you guys are on the last slide. So we're gonna go over just like 4 of these slides really quickly. So first we're gonna go to slide 12. So if everybody can move to that, or actually, I think I can like make you go to that.
The last slide was 19, right?
Yes.
Yeah,
Mhm.
I just
I think
for that.
everything should be on 12 right now. I think, maybe. A lot of you guys are still on the last one. I don't know why that's happening. But anyway, slide 12 was the one about like, it's the ones with the sign diagram. So basically on the table that you did in the beginning, you should have gotten like somewhere around 0.766 for all of your answers. So if you like rounded, it might have been a little different, but basically it was all the same. So this is because sine is like, you take the angle and then you convert them into side ratios. So every right triangle with a reference angle of 50 degrees, the ratio of the opposite side to the hypotenuse will be 0.766. So this is because like, if you think about it, let's say I have like a triangle with a 50-degree angle and a 90-degree angle. Well, I can change the side lengths to be like a bigger triangle or a smaller triangle, but like the way the triangle looks, like its shape, it's gonna be the same every single time. So since it's the ratio of the sides, then a ratio, like if you change, like if you multiply both the sides by 2, for example, the ratio will still stay the same, right? So that's why sine of 50 is always going to be 0.766.
You could also think of them as similar triangles. So like all right triangles that have a reference angle of 50 degrees, like all those will be similar because they'll have a right angle, and in other words, a 90-degree angle. They're going to have a 50-degree angle. And then they will also have a 40-degree angle because, you know, all the angles in a triangle add up to 180 degrees. So all of these triangles are similar. It's just they have, their sides are just multiplied. So the ratio will always be the same. So sine 50 degrees is always going to be the same, no matter what.
Yeah. And we're going to go to, let's see. We'll go to 16 and then 17. I think this should force you to move. I don't know why some of you guys are like still on the other sides, but
I think it does force. It's just maybe it doesn't update on your side yet. I'm not sure.
maybe. I think it's like lagging, but there's some people that are on random sides that aren't 12 or 16. So if you're one of those people, if you can just like move to slide. Okay, so 16 was asking for the cosine of angle C. So this one and tangent were one of the more harder ones, I guess, that a couple people got wrong. So basically cosine, somebody just tell me like which two sides you use and what's like, is it, I don't know, hypotenuse over adjacent, something like that. Yeah, so it's adjacent over hypotenuse, not hypotenuse over adjacent. Since it's so ka-toa, it's C-A-H. And the first letter is the C, which is cosine. The second letter is adjacent, and that's the one that's the numerator. So that's the one that goes on top. And then the H is the hypotenuse, which would become the denominator. So for this one, if I use angle C as my reference, adjacent would be 3, and then the hypotenuse is 5, so it'd be 3 over 5, which is what most of you guys put. So good job. And then the next one is tangent. And tangent is, somebody tell me what it is.
Opposite over adjacent.
Yep. So it's SOHCAHTOA. So TOA is TOA. That's why it's opposite over adjacent. Here, the opposite side is 4, and the adjacent side is 3. So it would be 4 over 3. And yeah, I think that's all we'll do with the Desmos for now. So everybody can just leave that and come back to the Zoom meeting. I'll pause the activity. And I think you can't do anything anymore.
Advika, about your question, in a, let's say we have like a 3, 4, 5 triangle. Well, actually, let me just say, the reason why sine 50 degrees is always near like 0.76 is because if you have like another triangle, like a 3, 4, 5 triangle, the angle wouldn't be 50 degrees. The angle, wait, let me see, what is the angle? You know what, that doesn't matter. The in like other triangles, they have different angles. So like in a 3, 4, 5 triangle, they would have a different angle that whose like sine would be like 4/5 or 3/5 or something like that. So so there's a lot of different triangles, but they have different angles. That's why in those triangles you couldn't do sine 50 degrees because there wouldn't be a 50-degree angle to use sine on.
Does that make sense? Okay, yeah. That's a good question though. So like, in fact, in a 3, 4, 5 triangle, one of the angles would be 36.86989765, and then it keeps going on, degrees. This would be one of the angles in a 3, 4, 5 triangle. And if you type sine and then like that weird 36 degree angle into your calculator, you'll actually get the ratio of, you'll actually get 3/5, which is the sine of one of the angles in a 3, 4, 5 triangle. So back on the slideshow. So here it's just telling you that for geometry problems, it's really helpful to draw a picture. So next, we're going to do angle of elevation and angle of depression. So this is kind of confusing, and especially if you have a word problem, it's really easy to get them mixed up. So basically, the angle of elevation is the angle, like if you imagine someone on the ground looking up at an object that's like in the sky. So like on this diagram in the bottom, the person would be like right here, and they'd be looking up at something that's here. So the angle of elevation would be this angle. Now the angle of depression, so angle of depression, no, it's not about being sad. The angle of depression is kind of like, so it would be if you're actually on top here, and the thing you're looking at is down here. So depression would be here, and the thing would be down here. And the angle would be this angle. So yeah, basically that's it. But like, I guess we can go through it. You'll see what I mean more when we do actual questions. Okay, so example, we're just gonna go through this. So you're standing 50 meters from a hot air balloon that is about to take off, and the angle of elevation to the top of the balloon is 28 degrees. Find the height of the balloon to the nearest integer. So we're going to draw a vertical line, and this is going to be our hot air balloon. The bottom of the line is the bottom of the hot air balloon, and then top of the line is the top of the balloon. And the ground is a horizontal line like this, and you're standing 50 meters away from it. And the balloon is perpendicular to the ground, so you can assume that the angle is a right angle. And now I'm going to complete the triangle, and we're going to add the angle of elevation because, well, the question tells us, but also because the person, well, what happened? The person is at the ground and they're looking up at something that's elevated. So that's why we're using the angle of elevation. And if we just solve this, well, here it just tells you that either of these triangles would be right because it's just like one of them is a reflection of the other, right? It's just flipped. Sorry, something's like going on with my computer. Oh, there you go. Okay, but these two would be wrong drawings because so where you place the angle is very important, and also where you place the sides. So this one wouldn't be right because that would be the angle of depression. Well, actually, no, it wouldn't be the angle of depression. It would just be like the angle of depression would be over here. This is just an angle of the triangle. The angle of elevation would be this one. So that's why this one's wrong. This one, the lengths are all messed up because you're like right here, right? And you're looking up to the top of the hot air balloon. This is a hot air balloon, guys. And you're standing 50 meters from it, but that's like on the ground. So that's why this one is 50 instead of this being 50. So either of these would be right. What is this triangle one saying? So now we're just going to solve for x using this diagram that we drew. So somebody tell me which trig function we should use.
It would be you have to have the cosine.
Cosine? So which two sides does cosine use?
Adjacent and hypotenuse.
Okay, tell me which sides are like we know on this triangle.
Adjacent and hypotenuse.
So we're actually trying to solve for this x, right? So what is this x?
Isn't it the opposite one?
So that's the opposite. And we're in our like equation, it's going to be some kind of trig ratio of 28 equals some kind of fraction, right? And one of these has to have x in it because that's what we're solving for.
Oh, I thought that those two is equal to that.
So if this is the opposite, and what is this one?
Adjacent, so tangent.
Yeah, so you would use tangent. So it'd be x over 50. So you would do tangent of 28 equals x over 50. Now you just have to use a calculator because you don't really want to do this by hand. And Amy is showing us the answer.
And then we multiply both sides by 50 once we do tangent. So it would be tangent 28 times 50. And the answer would be, I can't read it because I'm pointing it at the screen.
Just negative 14.
26 point something.
Yeah, 26.59 around.
Yes. So that would be x. So did that make sense?
I got, when I put into my calculator, I got negative 14.
Uh-oh. Let's see. Oh, you have it on radians.
Oh, okay.
So change it to degrees.
Oh, and
No.
it says nearest integer, so sorry. Yes, you're right.
Oh, I'm sorry, I got it wrong then.
So you're right, Charles. So is anybody confused about this? So the hardest part, in my opinion, is actually drawing the diagram correctly. But elevation is just like the thing you're looking at is elevated. And that's why you're looking up. And it's the angle that's like your line of sight and then the ground.
Angle of elevation is like if you look straight and then you lift your head. And then angle of depression is like if you look straight, but then you kind of dip your head.
Because you're depressed.
Yeah.
And if you like don't completely understand right now, I think it's okay. If you have more practice, you'll probably get it. So yay, speaking of practice. Wait, what? Why did it go to this? Oh, okay, there we go.
Just asking, do you have a Kahoot today?
No, sadly, no. Our fun activity
Okay.
today was the Desmos. Okay, so I'll put this link. Wait, I think it says viewer.
Yep. Everyone can edit,
Oh.
hopefully. Yeah. So for this, you just for each problem, like just pick a box and then write your name there and then draw the picture to represent the problem. You don't need to solve it yet. Just draw the picture that represents it.
What do you mean draw the picture that represents it? Oh, okay, never mind.
I think there should be enough boxes.
Why does this have a drawing? Oh wait, no, this one's solving.
It's okay if your lines aren't very straight. He's not on the cliff. He's at the base of the cliff. If he were on the cliff, that'd be kind of weird.
You wouldn't call Desmos fun. So you guys all like Kahoots better?
I think Kahoot's more fun, but Desmos is probably more educational.
Maybe it's like a different kind. Like, I don't know. I guess I would like Kahoots more, but in class, if my teacher told us we're doing a Desmos, I'd be happy because it's better than a normal, just like class. And if you guys like, when you're done, or if you're stuck, you can just like say so in the chat. Wow, so your drawings are very nice. we'll do this until um okay. Amy, should we skip the practice problems?
Is it glitchy for you guys too? Oh, never mind. It was just like in it was like pixelated for a second.
Oh, okay.
Do you mean the practice problems on the slides?
Yes. 'Cause-
Yeah, we can skip those.
Yeah, it'd be I don't know. Should we do practice problems and just not go over it? Or
I mean, there are problems on these slides, so
I think now after this, everybody just like tell me on a scale of 1 to 10. You can like private message me if you don't want to like tell everybody. Tell me how you feel on a scale of 1 to 10 after you do this Jamboard about what we've learned so far.
you guys are working so hard on your drawings.
Wait, okay, I'm just asking.
They look great.
If you know two sides of no mind, because then you could just use Pythagorean. No, if you have to use trigonometry and you knew two sides of the triangle and you knew one of the angles and then how would you find the last side? Could you just use either one?
And so like, yeah, you're right. So you would need two sides and an angle, but most of the time when you're doing like a problem, usually one of the sides or the angle would be like X. So that's the thing you'd be solving for. So you would
I know,
like,
but I'm saying if you had hypotenuse, this as an example, you had the hypotenuse and you had the adjacent,
Mhm.
and you had to find the opposite, then how would you, like, which operation would you use? Because there's two that you could use, right?
You can use
Yeah.
like either of them.
Okay.
Yeah, it should give you the same answer. And whoever is like scribbling on the problems. I like your drawing, but it makes other people not be able to read. Hey, who did that? Oh.
Like when I solved it,
Yes.
yeah, I had a question. So when I solved it, for some reason on my calculator, it showed that the tangent of 45 is 1, but then when I looked on the like Google calculator, it showed like 1.619 something. And then when I multiply it by 175, it gave me a completely different answer.
I think that's because Google uses radians.
Maybe.
Oh.
It
Yeah.
should be one.
Tangent of 45 degrees is 1.
Oh, okay.
But just a thing, the angle of elevation is
it's
42. Yeah.
Okay.
Oh, that's why I got it wrong.
Yeah.
And we're gonna go over just the first problem, like the one we're talking about right now. So after, like, you guys can keep going if you want to, but in like 1 minute we'll go over the 175 feet one.
Someone keeps erasing my drawings. It's annoying.
Okay, so I think we should go over it now. I'm gonna use this so that nobody can erase mine. Okay, so everybody basically drew the diagrams, right? Mine's not gonna be as amazing as some of yours, but. So this is the cliff and I'm gonna make the height X. Then I'm 175 feet from the base. So I'm right here. Yay, that's me. And the angle of elevation is 42. So the angle of elevation is the one where you like Amy said, you look straight and then you look up. So it's gonna be this one. And now I'm gonna use a trig ratio and I'm gonna use tangent because the side lengths I have and I'm looking for, the one I'm looking for is the opposite and the one I have is the adjacent. So I'm going to use tangent because it's TOA, opposite adjacent. So tangent of 42 is equal to x over 175. And now I just use algebra, multiply both sides by 175. And now x is something that I didn't solve yet, but Amy did.
And then multiply by 175 to get, is that right?
You say
Yep.
157.57, something like that.
Yes.
Okay. So to the nearest integer, it would be 158. Okay, so now we're just going to go back to our slideshow, learn one last thing, and that's it for this class. So I'm going to skip a little bit to slide here.
Heron's or Heron's.
Homework. I had a question about the homework.
Yes.
So, like on the homework, will you ask us these like hard problems that you just showed us right now, or will we have to know where the angle of elevation is?
We don't know yet. We probably will change. If we do have, we probably won't have 2 hard problems. There might be 1 or 2 though.
Okay.
Yeah.
If there are, could you make it so we don't have to put into a calculator and everything and just make it so it's like this over this? Just write out the equation.
Maybe. Well, we may need you to put in a calculator because it's kind of hard to know what sine 35 degrees or something like that is. So you may keep a calculator handy during the quiz or the homework thing,
Yeah.
just in case.
So Heron's formula is, what is this white box? Oh, there you go. Okay, so it's this, and there's like 4 variables in here, right? So A, B, C are the side lengths of the variable, I mean, of a triangle. And it doesn't matter which side is which variable. So like if you look at the red triangle, I could have made the longest side C instead of A. It doesn't matter. And the S is the semi-perimeter. And that's just means half. So half of the lengths combined. So it'd be half of A plus B plus C.
When would you ever use that?
So we'll talk about it in just a second, but basically if you have like the side lengths of a triangle, you can just find its area. It's really useful. Okay.
Oh, sorry. Yeah, so we're gonna do some quick practice finding the semi-perimeter of a triangle because you use that in Heron's formula. So just type your answer in the chat. What's the semi-perimeter of triangle A and triangle B? Just remember that semi-perimeter is just half of the perimeter. So it's nothing special.
And if you want, you can use a calculator for this.
Okay, yeah. It looks like almost all you guys got it. So you just add up the side lengths of the triangle and divide by 2. So for A, it would be 5 plus 8 plus 7 divided by 2, which would be 10. And for B, it would be 45 plus 22 plus 38, all of that divided by 2, which is 52.5. That's it. That's the semi-perimeter. That's just the S in the formula.
So we're just gonna like go over this example. You don't have to solve it, you can just follow along. So for this one, the only thing we know about this triangle is the side lengths, right? So that's when Heron's formula is really useful. So first we need to find S, the semi-perimeter, right? And to do that, I just have
a quick question. Couldn't you also just do 5 times 7 divided by 2?
So actually no, because the formula of a triangle is its height times base times 1/2.
Oh, I forgot.
Yeah, and
I thought it was 2 sides.
Like I don't know how long the height is, so I can't actually just multiply. So first I'm going to find S, the semi-perimeter, and I'll just add all the sides and then divide that by 2, which gives me 10. Now, using the different side lengths, I'm just going to put them into A, B, and C. The order doesn't really matter, but right now I put A as 5, B as 7, and then C as 8. And then for all the S's, you substitute 10. Then you just simplify. So this becomes the square root of 300 or 10 radical 3 when you simplify. So that is the area of this triangle. And obviously, in a lot of more problems, there's probably going to be a much quicker and like less, just lots of calculation to find the area. But if you don't have like that information available, then Heron's formula is very useful.
So let's, oh, sorry.
So yeah, just go ahead. Yeah.
Yeah,
Well,
we can. Oh, did you say something?
No, I said we'll do like one problem since it's like 426.
Okay. So for this problem, the question is basically find the area of triangle NOH. Oh.
I thought something would show up in the box first.
Oops, so pretend you didn't see that. So you guys can try to solve this by yourself, or if you want a hint, well, you have to also explain how you solved it.
Yes. Because some of you guys somehow saw the answer. I don't know how that happened.
Yeah, so try as a hint, what do you need in order to find the area of triangle NOH? Yeah, you need to find line segment, the length of line segment NO. So you would use the Pythagorean theorem to solve for line segment NO because it's just 6 squared plus 8 squared. That's, you know. So 6 squared plus 8 squared equals 100. And then you square root that to find that line segment NO has length 10. So now we have the three sides of triangle NOH. So now we just use Heron's formula to solve. And for that, you can absolutely use a calculator because otherwise it would be a bit difficult. So for this, we need to find the semi-perimeter. So the what would the semi-perimeter of NOH be?
18.
18.
Yes, that's correct. It would be 18. And then the A, B, and C are just the sides of the triangle, which we can just sort of plug into our formula. So writing it out, it would be the semi-perimeter under the square root. It would be the semi-perimeter times the semi-perimeter 18. Oops, 18 times 18 minus 10, and then times 18 minus 10 times 18 minus 16. So at this point, I would just type it in your calculator. So that would be this, it would end up being the square root of 2,304. So taking the square root of that is 48. If you didn't have a calculator, you could still calculate it. You would have to simplify the radical, which would take a little bit more time.
Any questions?
Wait, how's it 48? Wait, how'd you get 48?
18 times 8 times 8 times 2 is 2,304. And then if you square root that, it gives you 48. You might have typed it into your calculator weird.
Yeah, I did.
Okay.
So if nobody has any questions, then you guys are free to go. Thank you for coming to class. I think there was somebody that said they weren't here last week and they were a little bit confused about what we did last week. I think your name was like
Bye.
Harsh. I don't know if I'm saying that right. But if you're that person, then oh, you're fine now? Okay, then you can go. Thank you for coming, guys.
Bye everyone.
See you next week. Don't forget to do your homework.